So we begin these revision videos of Introduction to Probability with some basic definition and notations that you will be continuously using, which are obviously I'm sure you're familiar with, and you can just consider this a refresher. I won't focus on this part of the module too much, but obviously it is fundamental, so I'll have to go through it. But again, I'm sure you're familiar with all of the material, and maybe just one or two things I just mentioned here and there as quick reminders. So obviously we have a set, which is a collection of objects defined by these curly brackets. Note in calculus 2, these curly brackets were used for sequences, but obviously in probability, these curly brackets represent sets. And obviously order does not matter, hence the reason I've got or wrote 246 equal to 426. And then you have the combination of those three numbers. We also have sequences, which is an ordered list. Hence the reason that 1, 2, 3, 4 is not equal to 2, 1, 3, 4, because order matters despite them having the same elements. We have a function which is consists of two sets, the domain and the codomain. One thing to note is that if in the questions of a question like, is this meaningless, is this a sentence, is this a function, blah blah blah, those type of questions, if you're given a function and if what's inside the function is not a set, then you can be sure that part of the question is a meaningless. So that's just one thing to look out for. We have sentences / statements. They are constructed from mathematical objects by means of relational operators. This isn't necessarily the mathematical definition of a sentence, but it is what they do. But this isn't the formal definition. So yeah, or at least as far as I'm aware, he hasn't defined this as the formal definition. Then we have our operators for arithmetic, which are obviously plus, times, and minus, or plus, times, minus, and division, and divide, I should say, which I'm sure you're familiar with. They turn numbers into numbers, hence obviously we can't have sets on either side of these, for example, because that would be illegal. Similarly, with set operators, union, intersection, difference are supposed to be quotation marks, and symmetric difference. Obviously these turn sets into sets, so we cannot have a number on either side of these operators, because that would be mathematically illegal and not correct at all. Then we have our relational operators. They turn objects into sentences, so they might take two numbers and construct a sentence about it, or two sets and construct a sentence about it. One thing to note, we got improper subset and proper subset. An improper subset, that simply means that it is equal to the set it is a subset of. So for example, the set 1, 2, 3, an improper subset would be the set 1, 2, 3, but a proper subset of the set 1, 2, 3 would be 1, 2, because the proper subset has strictly just some of the elements of the set, not all of them, and that is a difference, very minor, but yeah, just thought I'd throw that in there anyway. Then we have logical operators. Camera's a bit shaky. So then we have logical operators, not, and, or, and obviously only if. You also have if and only if. The two imply signs. Forgot to write that one down. Perhaps I should just write it. So this was if, and only if, and obviously these are all used to take sentences and make more sentences, and that's what they're used for. So you can't have a set on either side of these, and unless it's cooperating to make some sort of sentence. That's the key part of this, and yeah. So that part's relatively covered, and that's relatively straightforward for the most part. Then we have false or meaningless. This is what I probably wanted to focus on the most, because this part of the module is relatively easy, but obviously false or meaningless, well, they are different things. When we say false, we mean that it's grammatically incorrect, and we mean that this is just focus. So we say that it's grammatically incorrect. As for meaningless, we mean to say that if something's meaningless, it's sort of mathematically illegal, as I had stated before. It's not correct mathematics. It's nonsense, if you like, and it doesn't mean anything. So for example, if we have a quick example, if you have 5 is equal to 7, this is a false. This is obviously false, but it's a sentence. It's a false sentence. So is it meaningless? No, because you'd define it as a sentence in the exam. But obviously, what the sentence is saying is not true. And so to say that 5 is equal to 7, it is not correct. But you're by me writing 5 is equal to 7, that sentence is fine. You see, so it's not meaningless. It's just false. Another example perhaps would be the set 5 is an element of the set 1, 2, 3. Again, this is a false sentence. A set 5 is not an element of the set 1, 2, 3. However, it is a sentence because I've just said it then, that sentence there. The set 5 is an element of 1, 2, 3. This sentence is not true, but it's still a sentence and it still holds. So it's not meaningless, and that's the point I'm trying to make. Something that would be meaningless would be like something, 7 set difference 2. Again, like I said before, these operators take sets and turn them into sets. So we need to have sets on either side in order to be mathematically correct. So this is meaningless. In order to make it meaningful, 2 and 7 would need to have set brackets on either side, and thus now this is a meaningful sentence, and we would define this as the set of 7 set difference 2, which is trivial, but nevertheless it would be defined as a set. So that's all I wanted to cover in this part of the module. Hopefully this is clear. Obviously, if I make any mistakes in this video or any future videos, please do say. I am prone to these mistakes. So I'm a student as well. So please do point them out. It'll be very helpful. And yeah, I think that's it.